Good morning to all. Myself, Dr.R.REKA, Assistant Professor, Department of Statistics, Sri Sharda College for Women, Salem. Now I am going to talk about measures of central tendency and measures of dispersion. Measures of central tendency. It is nothing but it is a typical value of the entire group or data, which describes the characteristics of the entire mass of data. It reduces the complexity of data and makes them to compare. It is generally called a measure of central tendency or the average. The following are the important types of averages, that is arithmetic mean, median, mode, and geometric mean and harmonic mean. Arithmetic mean, it is nothing but it is a series is equal to the sum of variables divided by the number of observations. The formula for arithmetic mean is x bar equal to add all observations, that is x1 plus x2 plus x3 plus etc xn divided by the total number of observations, which is denoted as capital letter N. That is x bar is equal to sum of x divided by n. For example, calculate mean from the following data. So the variable is marks. Solution. Here we have to calculate the mean. The formula for mean is x bar is equal to summation x divided by n. Here we have to take the variable mark as x. So first we have to calculate the summation x. So summation x, which is equal to 40 plus 50 plus 55 plus 78 plus 58 plus 60 plus 73 plus 35 plus 43 plus 48, which is equal to 540. So which is the value of summation x. And then we have to find out the capital letter N. Capital letter N, which is nothing but total number of observations. So here we have 10 observations. So n is equal to 10. So now we calculate summation x and n value. Just we substitute these values in our formula. That is x bar is equal to 540 divided by 10. That is arithmetic mean x bar is equal to 54. Next one, median. Median refers to the middle value in a distribution. In a series of individual observations, if the total number of items is an odd number, the value of a middle item is median value. For example, x is equal to 10, 15, 9, 25 and 19. There are 5 observations. First, we have arranging the ascending order and or descending order. Here, first one, we prepare a table. First one serial number and second one size of item in ascending order and size of item in descending order. So here middle value is, that is median value is 15, or otherwise we have to use the formula median is equal to size of n plus 1 divided by tooth item. That is here n value is 5. So size of 5 plus 1 divided by tooth item. So size of third item. So here third item is 15. So median value is 15. Next one, suppose in a series of individual observations, if the number of item is even, the median value is the average of 2 items in the center of the distribution. For example, here we have 6 observations, that is 8, 10, 5, 9, 12 and 11. Here we have to calculate the median value. First we arrange the order, ascending order or descending order. After that, we have to take middle value, middle of the two values, then divided by 2, or we have to use the formula median is equal to size of n plus 1 by 2th item. Here n value is 6, so 6 plus 1 by 2, that is 7 by 2, which is equal to 3.5. So the size of 3.5 item, that is size of third item plus fourth item divided by 2. Here third item is 9 and fourth item is 10 divided by 2. So 19 by 2, which is equal to 9.5. So the median value is 9.5. Next one, mode. Mode is the most common item of a series. It is the value which occurs the greatest number of frequency in a series. For example, 10 persons having the following income, like rupees 850, 750, 600, 825, 850, 725, 600, 850, 640, 530. Here 850 rupees repeats 3 times. Therefore, the mode is rupees 850. Suppose in a certain cases that there may not be a mode, or there may be more than one mode. For example, we have 5 observations: 40, 44, 57, 78, and 48. So here there is no repetitions. So here no mode. Second one, 45, 55, 50, 45, 40, 55, 45, and 45. So here 45 and 55 are 2 times repeated. So this observation having bimodal mode. When we calculate the mode from data, if there is only one mode in the series, it is called unimodal. If there are two modes, it is called bimodal. If there are three modes, it is called trimodal. And if there are more than three modes, it is called multimodal mode. Next one, geometric mean. It is defined as the nth root of the product of n items. If there are two items, we take the square root. If three, the cube root, and so on. The geometric mean is never larger than the arithmetic mean. On occasion, it may turn out to be the same as the arithmetic mean, but usually it is smaller. If there are zeros or negative values in the series, the geometric mean cannot be used. Thus, the geometric mean is obtained by multiplying together all the values of the series and then calculating the root of their product corresponding to the number of items in the group. The formula for geometric mean is equal to square root of x1, x2, etc. xn. For example, the geometric mean of the series like 2, 4, and 8 is the cube root of 2 into 4 into 8. That is cube root of 2 into 4 into 8, which is equal to cube root of 64. So the answer is 4. So the geometric mean is 4. Then the harmonic. So it is nothing but it is the reciprocal of the arithmetic average of the reciprocal of values of various items in the variable. The reciprocal of a number is that value which is obtained dividing 1 by the value. For example, the reciprocal of 7 is 1 by 7. Of 9 is 1 by 9. Of 8 is 1 by 8. The example problem of harmonic mean is the monthly income of 10 families in rupees in a certain village are given below. That is, the income is 85, 75, 10, 75, 500, 8, 42, 250, 40, and 36. So now we have to calculate the harmonic mean. First of all, we consider income as the variable x, and we have to calculate the reciprocals of each variables. That is 85, x is 85. We have to calculate 1 by x, that is 0.01176. Next one, the variable is x2 is 70, so 1 by x is 0.01426. And next one, 10, so the 1 by 10 is 0.10. The next value is 75, so we have to calculate 1 by 75, so the value is 0.0133. So next variable is x5 is equal to 500, so we have to calculate the 1 by 500, so the answer is 0.002. Then the sixth one is 8, so we have to calculate 1 by 8, which is equal to 0.125. Next one, 42, so we have to calculate 1 by 42, the value is 0.02318. Then eighth variable is 250, so we have to calculate 1 by 250, so which is equal to 0.004. So ninth one, the variable is 40, so the reciprocal is 1 by 40, which is equal to 0.025. So last one is 36, so the reciprocal of 10th variable is 1 by 36, which is equal to 0.02778. So then we have to calculate the harmonic mean. So next, we add all reciprocals, that is sum of 1 divided by x, which is equal to 0.34631. So the formula for harmonic mean is n divided by sum of 1 by x. So here the value of n is 10, because 10 observations are there. Next one, we substitute all the values like summation 1 by x and n in this formula. So n value is 10. So 10 divided by sum of 1 by x value is 0.34631. So 10 divided by 0.34631, which is equal to 28.87. So the harmonic mean is 28.87. Next one, measures of dispersion. Dispersion is nothing but it is the measure of the variation of the items. The following are the important methods of studying variation, such as range, inter-quartile range, mean deviation, standard deviation. The range produces the simplest measure of dispersion. That is, it is the difference between the largest and smallest value of the given observations. Its measures depends upon the extreme items and not on all the items. It does not tell us anything about the distribution of values in the series related to typical value. Thus, the range equal to largest value minus smallest value, and the relative measure of dispersion R is equal to L minus S. The coefficient of range is equal to L minus S divided by L plus S. Next one, inter-quartile range. So interquartile range, it is nothing but It is computed by deducting the value of first quartile from the value of third quartile. The formula for inter-quartile range is equal to Q3 minus Q1. Q3 is third quartile and Q1 is first quartile. And next one, semi-interquartile range or quartile deviation is defined as half the distance between the third and first quartiles. That is Q3 minus Q1 divided by 2. Q3 is third quartile and Q1 is first quartile. Quartile deviation is an absolute measure of dispersion. The relative measure of dispersion, known as coefficient of quartile deviation, is calculated as Q3 minus Q1 divided by Q3 plus Q1. That is the coefficient of quartile deviation. The quartile deviation is an improved measure over the range, as it is not calculated from extreme items but on quartiles. Next one, mean deviation. It is nothing but it is the arithmetic mean of the deviations of a series computed from any measure of central tendency like mean, median or mode. The formula for mean deviation is summation modulus of d divided by capital letter N. Next one, standard deviation. The standard deviation is also called as a root mean square deviation or mean error or mean square error. The reason is that it is the square root of the means of the squared deviation from the arithmetic mean. It provides accurate result. In this method, the drawback of ignoring the algebraic sign in mean deviation is overcome by taking the square of deviations, thereby making all the deviations as positive. So it is defined as positive square root of the arithmetic mean of the squares of the deviations of the given observation from their arithmetic mean. The standard deviation is denoted by the Greek letter sigma. The formula for standard deviation is equal to square root of sum of x minus x bar the whole square divided by capital letter N. So here x is given observation and x bar is mean and capital letter N is total number of given observations. This is my reference. Thank you.